Hey everybody, welcome to the last lab data analysis video of the semester. So I'm going to be going over the data for the last lab. Remember that the last lab report 4, is optional. And so again, if you don't want to do it, you don't have to. Don't worry about it. Take a break if you want. We're focused on the final. But if you choose to do it, then if you earn a better grade on lab report 4, then I will replace than you did on one of the first 2 lab reports, then I will replace the lower grade that you earned on one of the first 2 lab reports with the lab report grade you got on the 4th lab report. I don't know if I've said lab report enough. So in this video, we're going to go over what we did for the 4th lab data collection, so that if you choose to do the 4th report, you can. So let's start by reminding ourselves what we did for the data collection. So I directed everybody to go to a website. I think it was isle.hanover.edu. And on that website, I asked you to go to a particular activity. And I asked you to increase the disturbance of a particular audio file up to about 60%, play it, write down all the words you could make out, turn it down to like 0, I believe, turn down the disturbance a lot, listen to it, and then turn it back up to 60 and write down which words you heard the second time. And then you were to submit to me the words that you heard the first time, how many words you heard made out the first time, and how many words you made out the second time. Now, this lab was meant to illustrate the role that knowledge can play in our understanding of speech. All right. So we have certain semantic schemas, all right, for what words comprise what phonemes go together, all right. And when we bring knowledge to the perceptual event, we tend to be a little bit more accurate. We tend to perceive a little bit more of a stimulus. So that's what this lab was supposed to demonstrate. And so what we hypothesize is that participants will hear more words in a disrupted, diluted signal after they know what they're listening to. Okay, so we expect people to, so our hypothesis is that people will report having heard more words after knowing what they were listening to than before they knew what they were listening to. And I think the excerpt was something from Dickens, Charles Dickens, I think. So let's see if it happens. So everybody gave me those 2 numbers, how many words they heard before they knew what they were listening to, and how many words they heard after they knew what they were listening to. And let's see if that difference was statistically significant. And bada boom, it was. Okay, so again, as always, we did a paired samples t-test like we've done for every lab this whole semester. You can see the mean number of words people heard before learning, so before they heard the undiluted section from the book, and then the mean number of words after they heard the undiluted section of the book. And that difference was statistically significant. All right, so here are the words, and I'm going to upload this to Blackboard. All right, but I want to highlight a few things. If we're making a table, all right, and I've put this in the feedback back on the first lab report, but the mistake continues to be made, so I just want to highlight this. If we're making a table, the purpose of a table is to present very complex information in a very simplistic, very neat, very straightforward way. And so, yes, our data is very simplistic, and so we probably ordinarily wouldn't need a table, but for the assignment, I'm requiring you to make one so that you have practice making tables. I also wanted you to have practice choosing the right data, because we don't just throw everything into a table. All right, we make tables that are organized by information. And so you wouldn't put everything that I put in that Excel table into its own table. You wouldn't do that, all right? You would choose to create a table. You would give the table a function. What do I want this table to display? Do I want it to display the descriptive information, or do I want it to display the information from the analysis? And then you would make a table for just the descriptive information, means, variance, standard deviation, observations, and a table for just the analytical information, average difference, t-statistic, p-value, all right? You would do one of those, maybe both of them, but you would do, I'm only requiring you to do one, so you do one of those, but you wouldn't put all of it into one smashing of a table, all right? Because each table wants to present information in a visually simple way. If you're throwing everything together, it's not visually simple. You're just throwing together numbers. All right, so you want tables to be coherent, to have a coherent message, to have, they will get complex on their own. You don't need to needlessly make them complex. All right, so you want to limit what you put in a table. Don't just throw everything in there. Okay. For a graph, graphs, the point, the purpose, the function of graphs is to visually represent a relationship. All right, if we're looking at the relationship, the differences between two groups or between two measurements, as we have been all semester long, we would use a bar graph and we would depict the means of each group. We would not depict the means, we would not depict the variation and the standard deviations independently, because those are properties, those are features, those are characteristics of the group measurements. They're properties of the mean. They're how much individuals vary from the mean on average. So we don't create new bars in a bar graph for our variance. We don't create new bars in our bar graph for our standard deviation. Our bar graphs should only have bars for our means. Now, if you want to get fancy and you want to put error bars on each of the bars representing the means, if you want to look up how to do that, cool. But you don't create independent bars for the variances and the standard deviations. I would prefer no representation of the error, the variances, or the standard deviations. I'd prefer no representation of those in a bar graph as opposed to independent bars representing them, okay? And that's not a preference. Once you understand the logic of, visualizing data, it doesn't make sense to visualize variance, like variance, the statistic variance and standard deviation independently as separate bars from the means, all right? Because again, variance and standard deviation are they're qualities of the means, okay? All right, so I'll have your data posted, okay? So you'll look there. For those of you who choose to do Lab Report 4, you have all the data. You'll have the Excel sheet, you'll have this video, and hopefully that will be enough to put together a good lab report. Okay, so again, what was our hypothesis? Our hypothesis was people would hear more words after having heard the entire intact, undiluted book section than before they heard it. Okay, and we found that people heard more words after they heard the undiluted section than they did before they heard the undiluted section. Okay. All right, guys, that is it for this video. As always, if you have any questions, send them my way. You need any help, want any guidance on the lab reports, just send me an email. But if not, that's it. And this is the last lab analysis video. So you're done. So I hope that you enjoy your break. Good luck with everything, and I'll see you later.